So in this case, we are going to look into the properties of our shapes, that is understanding of the geometry of the 2D shapes. As we do understand from the basics that we had working with the geometry of straight lines, there are some of the shapes that we also had in the use as we were working with the geometry of straight lines. So in this case, as we consider the two-dimensional shapes, which is the 2D shapes for the two-dimensional, what we need are the basics. What is it exactly that we are working with? So that is working with the two-dimensional shapes. That is also considered as flat figures. All right. These are also considered as flat figures or flat shapes that you've got two dimension. So that have two dimensions. That is when we are to consider the dimensions length and width. Those are the only dimensions that you must consider. That is working with length and what? And width. So sometimes, yes, there are some shapes that we consider where we have the height. When we consider in terms of the height, you'll be saying, I have got the base and the height. It is your understanding of, say, the formula to say that is the base, but the base what? There are only two dimensions that we consider, that base and that height. So in a normal consideration, they will be just taken as length and width. That is the basics of the flat figures that have two dimensions. Yes, there are some consideration that we have, a consideration of a circle. We cannot consider the way that it is length and width. By looking into it, we have the length. The circle on its own, if we are to stretch this one, it is giving us a straight line, which is the length. There are so many properties that are being taken from a circle, but it is also part of what those flat figures that we consider as what the two-dimensional shapes. But in our properties, we are not going to look into a circle. The first part that we are going to look is of the triangles. As part of your syllabus, what you need is to understand the properties of triangles, of which we had some of these properties before, if we still remember. When we worked with our grade 8 mathematics, I mentioned some of the properties that you need. So we're just going to add one or two properties and look into examples that relate to the triangles and also the four-sided shapes, which is working with quadrilaterals, four-sided shapes. So those are the basics where you need to understand each and every property. So I'll advise you guys to actually work with your grade 8 mathematics because you had these 2D shapes before. Only that we're just going to add one or two on those properties that we referred to before. So the first part, like I said, is going to be on the classification of triangles. Trying by all means to classify our triangles. So let's try to classify, that is classifying triangles. Remember the basic property of a triangle before we look into their types, how they are to be presented, this and that. Once you have a triangle, we know it's a three-sided polygon. That it has three sides, three angles, and three angles. Those are the basic properties that you must consider on a triangle. Try means what? Three. Try three. Three sides, three angles. So the sides can be equal, all of them. The two sides can be equal. The three sides can be different, all of them. The type of triangle can be a non-right angled, it can be a right angled triangle. Those are now the classifications that we want to look into. But as a basic property, a triangle, that's a three-sided shape, which has got three angles. And these interior angles, their sum will be 180 degrees. Each and every triangle. Whether you are going to give it a special name, it is a right-angled triangle, it is an equilateral, it is a scalene, it is what? As long it is referred to as a triangle, the angles inside, when you add them, this angle at this point, and this angle at this point, if you add all these three angles, you must obtain 180 degrees. So let's say this is A, B, and C. It simply means angle A plus the angle that is at B plus the angle that is at C. We must have what? 180 degrees. Just like what we had before on the geometry of straight lines, we're saying angles on a straight line, they add up to 180 degrees. As long you are given a straight line, the angles that will be on that straight line must add up to 180 degrees. The triangle also, 180 degrees. So do not confuse yourself, guys, between, say, a triangle and a straight line. They have the same properties when it is on the sum of angles. So these are some of what? Interior angles, the ones that are inside the triangle, interior. All right. So that is, this one is going to be used on any triangle. Anyone that you think of, anyone that you think of. All right. So the first triangle that I'm going to look into as we are to classify our triangles is the equilateral triangle. All right. So we have got the equilateral triangle. All right. So by the word there, equal, on its own, it is telling us that all of the given sides must be equal. So an equilateral triangle is the one that we are going to see with all sides being equal. So if it is triangle A, B, C like this, from A to B, it is equal, B to C, C to A. And the three angles will be equal. But remember, we said these angles, they add up to 180 degrees. But we are saying they are equal. So we have got three equal angles. So we divide them. We divide 180 degrees by what? By 3 to get each angle now. Remember, 180 degrees is for what? For the sum of the interior angles, but all of these ones, they are equal. So we can simply divide by what? By 3. So this is going to give us 60 degrees. Each angle is 60 degrees. So once you see a triangle like that, each angle is being 60 degrees, you'll be having 60 degrees here, 60 degrees here, 60 degrees here. Automatically, that triangle is what? An equilateral triangle. Or you can see it by what? Equal sides. So the indication of sides, guys, we had this one before. So we actually understand when we are given these lines like this, okay? Putting this one, and putting this one. It is an indication that they are equal. The moment we put 2 here, and we put 2 here, and this one remains with 1 like this, it is telling us another thing to say these ones are the ones that are equal. But if they put also 2 here, it means all of these sides, they're equal. So they can even put this line 3 here like that, as long equal number of these lines. It shows us the same thing. Okay, so that's the basic properties that you're gonna need. So let me just try to write something here. So we said All angles are equal. So all angles are equal. Okay. That is meaning to say that each angle will be what? Will be 60 degrees. So meaning to say each angle is 60 degrees. Okay. Since they are equal. Also, we talked about the sides. All sides are equal. That is of the same length. So we are talking of what? The same length. Same length in this case. Okay. Then also we referred to the sum, but this one, guys, I'm not gonna talk about this because it's for each and every triangle. Sum of interior angles must be 180 degrees. So that is the consideration, guys, that you're given. For an equilateral triangle, we can work it from there. All right, so let's move on to the other part, which is an isosceles triangle. All right, so let's consider an isosceles. All right. So working with an isosceles triangle, this time we have a condition where two of the given sides of this triangle will be equal. So given triangle A, B, C like this, we can have a condition where the length of AB is the same as that of AC. As long there are two sides, it can be this one and this one. It can be this one and this one. It can be this one and this one, as long we've got two sides that are equal. It is an isosceles triangle. So it follows that on that isosceles triangle that we are given, remember we said before from our grade 8 mathematics, if we have got a side like this, the angle that is opposite to that side, the angle, this one, must be equal also to the angle opposite to this side. All right, we go this to the angle, this one. The angles opposite what? Equal sides must be equal. So thus these angles in an isosceles triangle will be equal. The angle opposite this side, which is what? At B. The angle opposite this side, which is at what? At C. So we are simply saying angle B is equal to angle C from that consideration. So those are the basic properties actually that you need on an isosceles triangle. So let us just write one or two here. So he said two angles are equal. Two angles equal. We also consider two sides that are equal. So we can say, if you talk about the angles first, then you can say sides opposite. Equal angles are of the same length. Sides opposite. If you're given angles like this, remember, we mentioned the angles from sides. Vice versa, guys, it can happen that from these angles that are equal, you can move from this angle. It means this side. From this angle, it means this side. So if it is A, B, and C like this, it means AB must be equal to AC. So we are saying sides opposite what? Equal angles. Sides opposite equal angles. So this is the statement that I want to write here. So I'm going to write it in this way. Sides opposite. All right. Sides opposite the equal angles. Okay. Sides opposite the equal angles are the same. The same in length. All right. The same in what? In length. So meaning to say, in this triangle that we are given, if we have got the angles B and C being equal, all right, so like we have got on that triangle, angle B is equal to angle C. Therefore, the sides opposite those angles will be equal, AB and AC. So therefore, AB is equal to AC. That's a mathematical statement we are referring to. So those are some of the reasons when whenever we deal with geometry, remember it's all about the reasons. So whenever you are to state a reason, why is this equal? We can talk about angles opposite equal sides. We can talk about sides opposite equal angles. It depends from where are you from the sides or from the angles. Are you mentioning your statement referring from the sides? Are you referring your statement from where? From the angles. All right. So if it is from the angles, you work with the angles. If it is from the sides, we're going to say angle B is equal to angle C because of what? These are angles opposite equal sides. We are giving a reason like that. If we are talking about angles from the sides, we are saying angles opposite equal sides. But if we are talking about sides from angles, we are saying sides opposite what? Equal angles. All right, they must be equal in length. All right, so that is it. Another triangle which do not have any special property is what? A scalene. All right, not forgetting that this is still a triangle, so all the interior angles must be 180 degrees if you add the sum for each and every triangle, guys. Like I said before, each and every triangle we must have 180 degrees. All right, so like I said, another triangle is a scalene. So considering a scalene triangle, what is important here is that it has none of the previous properties from other triangles. This one, it is on its own. Its properties are different in terms of the angles, the sides. All sides will be of different length. And also the angles, all of them, they will be different. The angle at A is different to the angle at B. It is different to the angle at C. So that's whenever you're given such a triangle, this is 3, this is 4, this is 5. The sides, they're different. They're not the same. It means you're talking about what? A scalene triangle. So that's all. Angles are different. So all angles are different. That are the angles inside of the triangle. That is in terms of what? In terms of the size, they are different. Then all sides have different length. All right, so all sides have different, again, lengths. So that is the major case that you're going to have. There's nothing special about this triangle, guys. Everything is different. All right, then let's move on to the other type, which can be a scalene, which can be an isosceles triangle, but it cannot be an equilateral. It cannot be an equilateral. Let's be very careful about this one, which is a right-angled triangle. This one. So a right-angled triangle, guys. All right, guys. My machine wants to start while I'm working. Why is it like this? All right, no problem. Okay, so I was saying here, we have also a right-angled triangle. A right-angled triangle. So I want you to be very careful, guys, on this one. It has the properties of the previous triangles. The only special part is right-angled. A right angle, we said is what? 90 degrees. A right angle. Whenever we talk about a right angle, it's what? 90 degrees. So we're simply saying this triangle has a 90-degree angle inside. Only one. There cannot be two 90 degrees in that triangle. It's only one that we are referring to. So this type is the only one that we are referring to as a right angle triangle. It is only one, okay? Let me try to have it this way. Yes, like this, okay? So let's say we've got something like this. This is a right angled triangle. A right angled triangle. There is an angle of 90 degrees inside of this. It's a special case that we are talking about. It's a special case. Having this angle of 90 degrees, there cannot be two of them. It's only one. Guys, remember we said angles in a triangle, they add up to 180 degrees. So if we have a 90 degree here, it means angle A and angle C, the remaining ones, will be what? So what about the remaining angles? This is what we want. The remaining angles will be simply from 180 degrees. 180 degrees minus what? The right angle, the 90 degrees that is at B, this one. So if we subtract 180 minus 90 is what? 90 degrees. The remaining angles, this one, A and C, these are our remaining angles, this one. These are the remaining angles that I'm talking about from 90 degrees. So these two angles that are remaining, angle A and angle C, they add up to 90 degrees, these remaining angles. So therefore, we are simply saying angle A plus angle C that is remaining must give us what? 90 degrees. So there is no way that A is going to be completely 90 degrees. So what does it mean? It means angle C will be 0 degrees. Can we have a triangle that has a 0 degrees here? No. As long it is an angle that is inside a shape, it cannot be 0 degrees. It can be greater than 0, not 0. So thus, we cannot have 290 degrees in this triangle. As long as it's a triangle, we cannot have two of them. We can only have 190 degrees. And thus, if it is like that, on a right angled triangle, the 90 degree will be the biggest angle that we have, because these two, remember we said angle A and angle B, they add up to 90 degrees. Remember that. Angle A plus angle C, they add up to 90 degrees. So it means automatically there, angle A on its own, as a single angle like this on its own, automatically it's going to be less than 90 degrees. Angle C on its own, this one, automatically it's going to be less than 90 degrees. They cannot be equal to 90 because the two remaining angles that we are talking about, these two remaining angles, they add up to 90 degrees both. So we cannot find one of them being what? 90 degrees. It's impossible. So it means they are less than 90 degrees. So what does it tell us? Angle B, which is the 90 degrees, this one, will be the biggest one, the largest angle that we can ever have. And it follows that from the biggest angle, the side opposite that biggest angle is the largest side also. The bigger angle opposing the largest side. So that largest side is given a special name, which is called the hypotenuse. The biggest side that we can have is referred to as what? The hypotenuse. Just largest. So meaning to say these sides AB and BC will be the two shorter sides from the hypotenuse. Those are the two remaining sides, and they are shorter sides compared, because we said the one that faces 90 degrees is what? The largest side, the biggest one. So that is the concept. So guys, these are some of the properties that you can just put into consideration. And also, as you have got a right angled triangle, it can be a right angled triangle which is isosceles. It is possible that a right angled triangle is isosceles. when these two sides are equal. That one, you'll be having two angles that are remaining. Remember, I said the two angles that are remaining, they add up to 90 degrees. And these two angles that are remaining will be equal. Remember, we said angles opposite equal sides are equal. So these angles will be equal. If it is A, B, C like this, angle A will be equal to angle C. So you take the 90 degrees because these two angles, they add up to 90. Then you simply divide by what? By 2. So each angle will be what? 45 degrees. Angle A will be 45 degrees. Angle C will be 45 degrees. This one, it is a right angle triangle, yes. But at the same time, it is what? An isosceles. Let's go back to the isosceles triangle. Let's go back. Two angles are equal. Sides opposite those equal angles are also of what? The same length. So it can be a right angle triangle being what? Being isosceles. Or just a basic right angled triangle being a scalene where all the angles, they're actually different in terms of what? In terms of the size. This is 90, this can be 60 degrees, this can be 30 degrees. It means the sides, all of them will be of the different length. It is just a normal right angle triangle, just like a scalene. It is impossible for us to have a right angled triangle and being an equilateral. That one is possible because we said in an equilateral triangle, all angles are the same. So we cannot have 90 degrees here, have 90 degrees here, have 90 degrees here. It is impossible. It's no longer a triangle. So thus, a right angled triangle can never be equilateral. A right angled triangle can never be equilateral. It can be isosceles, it can be scalene. These are the properties that now you get in depth. All right? In depth. All right. Anyways, that is it, guys. Not wasting your time. Let me just have one or two here. So you said, okay, the remaining angles A and B is going to give us 90 degrees. Just try to remember these guys later on. So that's one angle. One angle is a right angle. Is a right angle that is what? 90 degrees. All right. Another part, the sides. All right. The side, the side opposite. Side opposite the 90 degree, the right angle, this one. Side opposite the right angle. The side opposite the right angle is called what? The hypotenuse. Is called the hypotenuse. Okay, so guys, I want you to know these properties. That's where you use those concept of your Pythagoras theorem, this and that later on. They are from a right angled triangle. All right. Then another part which is nothing to do like any of these guys. Like we have these triangles. All of these triangles that we have, they are further adjustments which can be referred to. All right. Let me have this part on the properties of these triangles. I also referred these ones when we're referring to the properties of straight lines. If we still remember, those are some of the properties that we can also put into consideration. In any triangle, if let's say we do adjust this triangle, we extend one of the sides like this. We just extend, right? We are given a triangle like this. Then one side is being extended, or one of these is being extended. The angles that are outside here are referred to as exterior angles outside of the shape. And remember, the ones inside are interior, inside, interior, or internal. So when we are given a triangle, let's say it has been extended, that is triangle ABC like this. The line or the length BC, side BC is extended to another point. Let's just call it D, like this. Let's concentrate on one length being extended, or on one side being extended. It can be AC extended like this. It can be AB extended like this. All right. So here we are focusing on BC being extended to D. So like I said, we have exterior and we've got interior angles that are inside the triangle. So on angle C, two angles are being created. So you can call angle C1 and angle C2. Two angles are being created. One being an exterior angle and the other one being an interior angle inside of the triangle. One is outside, one is inside. All right. So what are the properties that we can put into consideration when it is like this? The first property well known is that angles on a straight line, they do add up to 180 degrees. So automatically or by default, we can say angle C1. All right. So automatically here, we are saying angle C1 plus angle C2 must give us what? 180 degrees. Angles on a straight line. Angles on a straight line. Okay? So that's a property of this extended line. Another property is that the exterior angle that we are talking about here, which is angle C2, this angle C2, it is equivalent or equal to the sum of the opposite interior angles. Opposite, guys, the key word is opposite. Opposite. Interior angles. All right. So I want us to see what is the opposite there of the interior. This is our interior, the one inside, angle C2. C1, I mean, this angle C1. That's our interior angle. So we are saying the opposite interior. The opposite will be A and B. Those are the opposite that we are seeing there. So their sum must give us the exterior angle. So here we are saying the angle C2. All right. Let me write the statement first, then we're going to have a mathematical view on that one. So you're saying that's the exterior. All right. The exterior angle, I'm just going to write in short, guys. All right. Exterior or external. All right. So the exterior angle of a triangle. All right. Of a triangle, I'm just going to write in short, equals sum of the interior opposite. The interior opposite angles. The interior opposite angles. Interior opposite. That is the major case. What we see on the exterior, which is angle C2, mathematically here, it is angle C2 that we see here, this angle C2, must be equal to the sum of the opposite interior, A and what? A and B. Angle A plus angle B. So that's angle A plus angle B, just like that. This is our mathematical view. Any condition of these guys can be used. We have got P, Q, R, S. All right. So the angle that is, all right, let's say this is Q1, this is Q2. The angle Q2 must be equal to what? the sum of the opposite interior. This is the interior Q1, but the opposite now, angle R and S. Opposite interior. This is our interior, external, internal. But what is opposite to that is what we need. So that's angle R and S. This is our mathematical statement on any triangle where this is being formulated. So I want you to use this. They are going to ask a lot of questions on this property. A lot of questions. So this is it, guys. Do not forget some of the other properties that I talked about. Angles inside a triangle, they add up to 180 degrees. The Pythagoras theorem from your grade 8 mathematics, all those, they are to be considered in your revisions. So we're just going to look into some of the basic questions. Classify these triangles. All right, so there they just wanted you to classify. Can you tell us by just looking into the diagram, the triangle shown there? Can you do that? Okay, so number one, that was it. Then A, we are given the first shape. So looking into this, we can see a 90-degree angle. So meaning to say we are dealing with what? A right-angled triangle. So that's a right-angled triangle, this one, guys, without wasting our time. We've got our right-angled triangle. All right, B, we can see that all the given sides are different. So that's we're talking about what? A scalene triangle. All right, C, all sides are the same. As we can see, this line are the same. So that's an equilateral, this one. So that's it, guys. Just go through. Okay, these, they are different also. So we have got the same answer as on B. All right, on E, we can see that there are two of the sides which are given that are the same. So we are back to an isosceles triangle there. Okay, then F, all of the sides are the same, just like what we can see on ECAS. What is the difference? What is the difference? There's no difference. All right, so that's an equilateral triangle. As we can see, the G and the A that we had before, there is no difference. Again, a right angle triangle. As we can see, guys, there is a 90-degree here. So this is the same as the answer on A. Then our H, all right, two sides equal. So what is the difference with what? With E? There is no difference there. So you see, guys, they'll be just asking those silly questions sometimes, but as an individual, you must know all the properties so that you'll be able to classify. You cannot classify without knowing these properties. So we shall look into other questions in our next class so that we do understand all these basics. Where we do not understand, we can try to join the groups that are being displayed. So you can scan the code, join the group, you send your questions so that we can assist each other on those questions that we do need assistance on. So that is it, guys. Till we meet again.